with you. So thank you for the invite. And again, it gets so exciting when you're able to now report on a 12-year-old study of chestnut. And I do believe that, wow, it gets really interesting in all stages of development and growth. But I really love the longer term interactions that we're starting to see in the field. This here, I started this in my PhD work under my advisor, Carolyn Kiefer, who we also met, Sarah, at another conference before, and also Brian McCarthy. And this was a collaboration between Miami University, Ohio University, and now I'm at Western Washington University on the West Coast, still watching this site, taking data. And like I said, it's starting to get really, really interesting. So this is an old enough study. When we did establish it, or we started to plan for plantings, we didn't have the 15/16ths yet, and the transgenic weren't even really in the picture. Maybe they were kind of a vision, but they weren't really starting to work with that. So what we were working with were some of the older back-crossed hybrids. And I do find it important to at least report on and try to understand the resistancies sort of on a long term, maybe their applicability in agroforestry in the long term, and definitely looking at these planting methods as a way to get ready for the more advanced hybrids, and of course the transgenic, and how we're going to plant them and manage them, and the silvicultural treatments that we can apply on them in the long term, or in the field in the short term, and then see continual data on their growth and success. So I just wanted to point out for this study, we used the 3/4 back-crossed American chestnut, which is about 75% American chestnut genetics, and the 7/8, which is about 87% pure American. And then we ran it with our pure American chestnuts just to particularly look at how these hybrids are growing in comparisons to the pure American genome, and also whether or not they're showing resistance in the field to chestnut blight. So this field site here, talk about compaction. This is on a former surface mine landscape that was reclaimed using these methods that really cause a lot of soil compaction, because there's a lot of continual grading. Back in the day when they were mandated to green up these sites, there really were no native seed nurseries to pull from. So a lot of these landscapes have been reclaimed using maybe non-native species and continual regrading, which has really resulted in compacted landscapes with non-native species. And in areas such as Eastern Ohio, Lesbedeza was a big popular plant to use. And I'm sure you all see this in the Pennsylvania coal mine sites too. Lesbedeza is a legume used because it will add nitrogen to the soil. However, we're finding that even 30 years after reclamation, we're not seeing any movement to forest. Theoretically, they should start to succeed a bit into forest through just natural succession into forest recovery. You can even see the landscape. We have pockets of forest, so we have seed sources, but we just don't have the planting medium for a seed to be able to be moved around and actually have a successful establishment in a mine site that's very, very compacted and overrun by very aggressive forbs like Lesbedeza. So this is the mine site we had targeted. And the reason why we did is we were looking at that soil profile kind of generically. So we weren't too in depth, other than it had a nice sandy loam that checked that box, and it had a pH that we thought was conducive for chestnut growth and survival. And it was on a slope. So we had this nice slope that would hopefully guide water away from the chestnuts and allow for a nice medium for growth. So what we were really looking at is, okay, if we want to use chestnut, particularly as a potential restoration tree on formerly coal mine landscapes that we have a lot of in Ohio, I know there's a lot in Pennsylvania as well. What kind of planting methods can we establish or initiate in order to get a really good establishment on these chestnut hybrids, and sort of pave the way to understanding better planting methods for also the more advanced hybrids as well as the transgenic trees. So for this study here, we set up a a randomized block design. So, and each block is a treatment, and our treatments are as followed. We have a rip treatment here, where we took a bulldozer in with a 1 meter steel shank bar that we just cross rip the heck out of that site to really loosen up that soil. We also compared it to just a traditional plow disc that went about 30 centimeters in the soil, broke up a lot of that sort of thatch that was caused by a lot of that aggressive growth of the forbs, and it loosened up about 30 centimeters below that soil surface. And then we combined the two. So we deep ripped at about 1 meter depth and also plowed in disc that top subsurface there. The control plot was just left untreated with regard to compaction, but everything got just sort of this mow right before we started to initiate our treatment group. So we knocked back the Lesbedeza. We did not spray at this point. We just knocked them back, put in our soil treatments, and planted our trees. So at about a weekend, with thank you to Ohio volunteers from the Ohio chapter, they came out. We put almost 1,200 chestnuts in the ground in a weekend. They all got caged because, man, you guys know white-tailed deer run rampant in these mine sites. So you have to protect them or they'll just be gone within that first year with herbivory alone. So they all got chicken wire. They all got a little of that pterosorb, which is this auger type gel that you can add to the soil that holds in moisture. So we added that to the soil. We put in a little bit of fertilizer pellets and a weed mat. We really gave them A+ treatment. And then we walked away and we're just like, oh, please grow, please grow. So they really did. So the first year we got a lot of great establishment from both hybrid lines, also from the pure American. But I do like to point out, and you guys who have experience with the hybrids know that you're still seeing a lot of morphology that is linked to the Chinese parent on some of these crosses. So for example, after 1 year establishment, it was easy to see without even looking at the tag, what's a pure American. This is it on the left here, that nice straight trunk or stem starting to form versus the hybrids. And this would be the lesser variety, about 25% Chinese chestnut parentage, showing that sort of orchard tree morphology that you would come to expect with the Chinese chestnut. So really right off the blot, we could see a difference in growth by year 1. By year 3, they grew really well. Because like I said, we didn't do any type of herbicide to prep for this site. So we were really counting on the upright, fast growth of chestnut to get up and above that competing ground cover. And the chestnuts did not disappoint us. So after year 3, they were up and over the competing herbaceous cover. So they weren't in any way impeded by vegetation competition, at least by year 3. And then we put in a little spot spray of herbicide just to kind of ensure that they're continue their robust growth. We also looked, and I thought you'd like this, Laura, we also looked at Mycorrhizae. So we characterized within the first 3 years, and then afterwards it gets so hard to find a chestnut root from all the other stuff in the ground. But I think I'm going to try again here in the next couple of years, get a nice 15-year idea of mycorrhizal succession on these former coal mine sites. What we did see, we saw a big player, which was puffballs or scleroderma. They come in very early on chestnut, and then they tend to succeed a little bit into, let's see, this is a hebeloma. That was a very early colonizer, and then they tend to give way to this Cortinarius. And both the hebeloma and Cortinarius are mushroom forming fungi. And we also found the Cenococcum, which is a very interesting, has a very dark black hyphae and radiating, or I should say sheath, dark black sheath, and this neat radiating dark black hyphae. And again, like Laura was saying, definitely helps the tree maximize their ability to take up water and nutrients. And we did find a significant impact that our soil treatments have on mycorrhizal formation, and that agrees with the literature. The more oxygen in the soil, the more the ability for that tree root to really extend itself and to make its symbioses with its symbionts. is so critical that there's air and porous and ability for that symbiosis to form. So the soil treatments definitely boosted mycorrhizae functional symbioses in the field. After year 4, we were, like I said, these chestnuts continued to really amaze us on the site. They were tall, they're starting to cast shade on the ground, and they were reproducing by age 4. Well, they were really age 5 because they were planted as a 1-year-old bare root seedling. But after 4 years in the field, they started to form burrs. And that we found to be associated with our treatments. As long as we had some type of compaction treatment, we had lots and lots of reproduction of all of our chestnut lines in the field. So we returned at year 11 and we took some survival and growth data. So this is fun when you actually don't have to show charts and graphs to get your point across, right? Here we go. But then don't worry, you stats gurus, I'm gonna go into charts and graphs after this. But just, wow, we got a lot of great growth out of our plots that had that ripping treatment in there. Plow disc also performed in the early years. What we did see was, wow, this super growth from the ripped treatments where the plow disc kind of came in second, and they were just overwhelmingly taller and more healthy than the control plot. So you can see those control plots down here in the bottom right side of my PowerPoint. So after 11 years, that pattern of soil treatment just showed to be so important for chestnuts. Chestnut's ability to reproduce, chestnut's ability to find and maintain functional mycorrhizae in the field. And if we want to look at then survival by treatment, so I promised, right, charts and graphs, what we're seeing here is my neon green bars is survival. So on my x-axis, I have our treatments. On the y is whether or not they survive. So our green bars are showing that the plow disc, rip plow disc, as long as they had some type of soil treatment, they had much higher survival over time. So our rip plot did the best, but really on a significance level, as long as there's a mechanical soil treatment, there was much higher survival. And when we think about a coal mine reclamation project, when we get 70% survival on a site, we're thrilled. So the ripping method definitely really increased that ability to survive. And then if we look at height, so now we're looking at the same treatments on the x-axis there, control, plowed disc, rip plowed disc, and height as a metric on our y-axis here. You can see that, again, as long as we had that mechanical treatment, we had significantly taller chestnuts. We also saw this pattern repeat with our root collar diameter. That too is a nice indicator of growth, not only above ground, but it's also significantly related to below ground root growth. So we had a nice bolstering of both above, below ground root, as long as we had that soil treatment. Now, interestingly enough to me, and this again is going to connect, I believe, to what Laurel was saying in her talk, is that, remember I said in the beginning, if it was ripped, those plants took off and they were taller, they were bigger, with plow and disc kind of coming in second place. After 11 years and 12 years in the field, what we found is that the plow disc actually caught up. So I'm curious to see if, is 1 meter depth ripped deep enough to actually aid the chestnuts into that real deep root growth, and it may not. So if we're seeing this sort of catch up in year 11 and 12 with the plow disc trees, this kind of makes me kind of wonder if 1 meter depth is actually deep enough. But that's something we can kind of look into over time. When we look at survival, now we're looking and comparing our tree types. So when we ran our analysis, we didn't get an interaction between actual tree type and treatment. So that therefore we can look at each of our sort of treatments, both tree type and treatment separately. So now we're looking at our green bars are looking at survival by tree type. We have our 2 hybrids. So the BC1F3, that again was about 75% American chestnut. BC2F3 was your 87% American chestnut genome. And after 12 years, what we're seeing is an increase in survival on those hybrids. So both of those chestnut lines had significantly higher survival when compared to that pure American over time. So that's something that we saw that trend happening throughout the study, but after 12 years, those hybrids are recording a higher survival. And then when we look at the heights over time, we see then one of our hybrids are doing just as well as the pure American height-wise. Now, the question here, is it catching up with pure American over time? Because are we starting to see some dieback on the pure American? So I can't really say this is the morphology of this hybrid as much as it's probably the resistance that this hybrid is showing to natural blight affection that's going through the field. So I'd like to go ahead and kind of show you what we did to try to quantify and qualify blight infection. So we didn't release Cryphonectria. We did notice after year 4 or 5, just as those chestnuts were starting to reproduce, we started noticing small cankers in our field site. We didn't do anything to stop it or to encourage its spread, but we wanted to track that through time. So after 11 field seasons, we characterized stromas with different ratings. 0 means we didn't find anything that looked like a canker on those trees. For a rating of 1, it had some type of wound, and we really could not tell whether or not this was just sort of a freeze-thaw event. Maybe it was from wildlife, maybe it was from another pathogen, and we did not see any type of orange stroma that's generally associated with Cryphonectria parasitica. But we went ahead and ranked that 1. That's a 1 canker rating there. Or the one in the middle, this is a moderate canker. We see stroma present. We see some necrotic tissue forming. And then lastly, number 3, it ranked them severe cankers when we saw this overwhelming girdling, evident presence of stroma, a lot of necrotic tissue. That got that canker rating of 3. We also pulled bark plugs out of these trees, grew Cryphonectria out on plates to confirm that what we're seeing here in the orange pustules were Cryphonectria as they were identified growing out of that canker. So we do know that we do have for sure the presence of Cryphonectria. And then looking at those canker ratings, what I'd like to show you is on the bottom there on our x-axis, we have the 2 hybrids compared to that pure American. On our y-axis there, we have our canker ratings. So what you can see is after 11 years, the pure American had significantly more. So I'm just looking at this big fire orange red, I guess red-orange bar here showing that pure American had the majority of those real severe canker infections. They also had the moderate cankers, the stroma present, as well as some of those insignificant cankers as well. And this was significantly higher. This blight incidence was significantly higher on the pure Americans, showing that we do have some resistance building, or at least illustrating resistance in the field from these hybrids here. The BC1F3, I had mentioned that it was growing just as tall as the pure American, but just anecdotally, I guess I could tell you that as I was in the field watching these pure Americans kind of die back due to that canker infection, that the BC1F3s aren't quite growing as robust, say, as a pure American would, but they're showing such resistance that they are getting to be big, nice, reproducing trees in the field. So we also wanted to know, okay, after 12 years, 11, 12 years, what's growing with chestnut in the field? It was all Lesbideza pretty much. And then if you kind of parted that Lesbideza, there was a lot of fescue. So there was really very little native. One thing I did want to show, well, let me go back to that. But first, let's talk about herbaceous competition that was also growing around the chestnuts. We had Lesbideza did come back, but again, that's now an understory plant. It's growing underneath our chestnuts and they're starting to phase out. So they were pretty much about 80% cover before we started the study. Now they're sitting about 30% cover. Also, what's moving into the site is smooth brome. It's another non-native that can be invasive in some of these sites. That's at about 18%. So that's kind of the bad news. The bad news regarding herbaceous competition is we really are always going to have this pressure from invasive species that were seeded in upon original reclamation. But the good news is we're starting to see some native species come in as well and growing with the Lesbideza and the brome, and that would be the Canada goldenrod. That's coming in really, really nicely. Allegheny Blackberry, that's there, and always a good sign that your soil is really ready for trees to be planted in. And then we also have this tall fescue that was introduced, and what's kind of on the horizon there, we characterize it as herbaceous, is this Amur honeysuckle, is newish to our site, although there's plenty in the county, but we're starting to see this Amur honeysuckle come into the site. So we didn't see anything different among our treatments, but this is just showing that the site, we do have to continue to manage for invasive species. When we have our woody composition, pardon me, we're seeing Allegheny Blackberry. That again, we characterize it both as herbaceous when it's really little and growing around our trees. When they get waist high, they're really the more abundant woody species out there, which is good, except if you're tangled up in it. But for the most part, at least ecologically, it's really, really good. Your honeysuckle, again, is what we're going to have to seriously consider managing for over time. We also have some native species coming in, smooth sumac, poison ivy. That's also fun to be tangled up in. Good news ecologically, bad news if you're a surveyor, and then grapevine. So again, we really didn't see too much on differences across our plots here, but we did find some interesting plants out there, and that's these next generation chestnuts that are seeding themselves in from their parents, and we don't know their lineage because we don't know if they're crossing or what. But we are starting to see seedlings. So this could potentially be a nice sustainable population of chestnuts over time, we hope. So again, I had mentioned that they started producing nuts very, very young. I also mentioned that there could be some applications, not only as these hybrid chestnuts as restoration trees, but potentially as these chestnuts as an agroforestry crop in some of these areas where they're not quite being used for active farmland. They have the potential to succeed into forests upon correct planting methods, or they could be managed as an orchard crop. And again, they're producing nuts nicely. But our question, though, that being on a mine site, where the reclamation is a bit, unknown with regard to that soil profile. We do know that they came in, they extracted that coal resource, they filled in the holes with spoil material. What I mean by spoil material, it's rock material, parental bedrock material with chips of coal still embedded in that. So that can create a very acidic condition, as well as compromise your natural underground water aquifers. So we were kind of wondering, would there be an issue with heavy metals as those trees grow and root deeper? Because upon reclamation, they bury the spoil, they cap it off, they cover it, they bury it with, the specs say 18 inches of topsoil. And we know we rip deeper than that. So we were just kind of wondering if there's going to be any interaction with the chestnut roots and their ability to pull up any metals that could possibly translate into heavy metals in chestnut tissue. And importantly, if we're thinking of this as an agroforestry crop, into that nut material. So at year 12, we sampled the foliage and the nut tissue for heavy metals. And what you're seeing here, the green bars are our leaf tissue. The brown bars are the nut tissue. And of course, on the x-axis, I have leaf and nut printed out for you. On the y-axis are the levels of metals. And my gray background, or my gray bars that you see, are the natural range of these metals in tissue. So what we are seeing is manganese. Wow, chestnut is a hyper accumulator of manganese. In fact, doing a little literature search after this, I found that Chinese chestnut is used in China a lot for some of these reclaimed mine sites because they will hyper accumulate manganese. And it was playing out on our site as well. So the leaf tissue had so much manganese registering in that leaf tissue. However, when we looked at the nut tissue, and interestingly enough, it was really on the bottom sort of normal range of manganese. So that I think all of these data show that even if the leaf is sequestering some of these potential heavy metals, the nut tissue is not. So again, we have zinc. We did not have levels that even reached anything normal. Maybe we even have a deficiency here with zinc anyway. Cadmium here has levels far below anything that would be concerning with regard to ingesting, whether it's wildlife or people. Arsenic, we're low in the normal range of arsenic within that tree tissue, as well as copper. We are quite low in the leaf, and it is also interesting to see how different parts of the plant sequester metals differently. And in this case, they did have a higher level of copper within that nut tissue. However, it was not in any way a range that would be dangerous for ingestion. So after looking at these metals, and again, this is one site, sort of a snapshot. So I would encourage, more work that looks at the interaction of heavy metals and tissue if they are planted on mine sites, just to ensure that safety for wildlife that will be ingesting some of these plant parts, as well as potential for agroforestry crops within this area. So, okay, so a research summary here. Either soil treatment yielded greater survival, growth, and seed set. I am concerned that because our plow disc, which was only 30 centimeters of loosening up that soil, might not be deep enough. It might be indicative of the fact that our ripping event might not be deep enough to really ensure long-term survival. Again, these are now 12-year-olds. In this study, we're going to go back in a couple years and take another look. We do have reason to be concerned of Phytophthora. We saw some signs that Phytophthora might be lurking in our site. And we also want to take a look at Mycorrhizae after 15 years. So we're planning on returning and seeing how they do after another few years regarding that treatment and height and growth. We did see significantly less chestnut blight on our hybrid trees. So they're not the advanced hybrids, but they're nice trees. They're growing well, they're growing fast, and they're producing nuts. And that could, like I say, have a role in some type of agroforestry within some of these marginal landscapes. We will have to continue managing, at least for invasive species. I am nervous about that honeysuckle. They can come in and displace trees. Honeysuckle was not there prior to our study, so that's something that's moving in over time. I mentioned that we do want to keep looking at Phytophthora, and over time kind of keeping our eye on metal levels and ensuring that tissue is safe for the food chain, as well as possible human consumption. So I want to thank Western Washington University, Ohio chapter, American Chestnut. They provided funding for the study. It was set up on an original grant with the Department of the Interior. Those of you all who may have met Carolyn Kiefer through these, she brought her class out on a very beautiful fall day in Dresden, Ohio, and helped me collect all of these data. So thank you. And also thank you for the invite. I meant to start with that, Sarah. So I really appreciate the invite to this event today. Thank you.
Thanks so much, Jenise. Hey, we got a couple questions for you. And so one is from Steve Johnson Ball. Are you caging your volunteer chestnuts?
We're not. No, and that really is bandwidth, right? Time and field labor time too. But that, let me note that, because moving forward, we really should be. And next time we do return to the site in a couple years, we will check them out, flag them, and kind of add that on our list. And I'd like to take some tissue and see if we can't get some type of DNA analysis on their parentage too. So great question.
Yeah, I'd be really interested actually to not cage them, because I mean, right, the whole point of restoration and reintroduction is to see how these progeny do and follow up. And we, at some point, people might cage things, but I'd be more interested to see if you can flag them and follow them, are they able to withstand any sort of the predation or herbivory that that might just be interesting
Thank
to
you.
follow from that
Yeah.
perspective, and less work maybe, I don't know.
Thank you for that feedback. Less work, we can definitely do it. And you're right, it would, that is the goal. The goal is to plant and walk away.
Yeah.
So that would be interesting. I'm kind of torn, right, between, do we want to save this to collect for nuts, or just save it? And you're right, just have it play out on an ecological timescale.
And then I have a question about the ripping. So I've gone back and looked at a couple of our CIG sites, the Conservation Innovation grants that we got that Michael French helped install in Eastern Pennsylvania. I was out there a couple of weeks ago looking at these sites. And when we first installed those CIG sites, we thought that you could do one pass with the ripping bar. And it was a 4-foot ripping bar. So it was a 4-foot ripping bar on a D9 dozer, rip one way. I think since then we've seen that the cross rip is better. So rather than one pass, do one pass and then do another pass down a grid and then plant in the intersection of those grids. It was my experience, particularly in the Michael Cole in Tremont, Pennsylvania, that we had a lot of frost heave. We had a lot of root constriction still, despite the ripping. So I don't know if you can speak to, and maybe you cover this and I just missed it. So you were 30 centimeters down with your ripping bar, and then was it one pass or was it a cross rip?
Okay, thank you, Sarah. Let me clarify that. For the ripping treatment, we were 1 meter down, and we cross ripped and planted in the cross. That was that treatment. The other treatment was the plow disc. And the reason why we did that, and I'm sure you're finding, it's hard to find someone, and it's expensive to find someone to come out and deep rip. So we were also wanted to compare, okay, what would farmers have on hand? That would be a plow disc board, and that ripped 30 centimeters down. So those were the difference between those two treatments. Plow disc 30 centimeters, ripped was 1 meter, and then the mix of the plow disc ripping. And after 11, 12 years on the site, what we're seeing is those plow discs that were only 30 centimeters down catching up to our deep rip chestnuts. So that's why I'm kind of wondering, well, gee, are they hitting a hard pan that we just didn't get to, because there's very little that we do know about these soil profiles of these sites. And that right there is a whole cool study of getting a soil profile and understanding that a little more, getting a nice big soil pit out there. But again, time and money and getting to that site is challenging. So
I'd be really interested, and I think the ARRI guys, so the Appalachian Regional Reforestation Initiative, ARRI, I think they've done some evaluation, and I'm not really up on it, of the parent material and how much that affects whether or not. So, and I know that there's some differences. I wish I knew off the top of my head, like, brown parent material versus the blue parent material, and I don't know enough about it to speak real well about it. But I would be very interested in going back into some of these sites. We've got 12 of these CIG sites plus the ones that you've installed, doing some of these pits and looking how much compaction is still there, between the ripped areas. What is the parent material and how is that interacting with the chestnuts growth? Because your growth is much better than what I've seen on some sites. Now, on other sites, they've done well. We do have 30-foot fruiting trees on cross ripped sites, so it can work.
Right. I love it. And in fact, let's talk a little more, because it would be great to get something not only about the depth, the root architecture. I'm also curious about mycorrhizae, how root depth is influenced by competition, how mycorrhizae are stratified in that soil profile. I think we have so many questions to answer. So let's keep talking about that. And maybe if you end up with something, or we'll talk, maybe we can see if we can return to some of these sites and do depth. profile.
And so real quick, just do you see any frost heave on your sites or on this site with the ripping?
Well, I have in the past. With fall plantings, they just pop out of the ground. We did a late spring planting, early spring. It was March, 2007, and we think that timing helped with that frost heave. How about you, timing wise of planting?
This was a nut planting in early spring, and it looks like it's more, and I've had that issue with fall plantings. I do have frost heave issues more in the fall than I do in the spring, but that's why I was so surprised to see that on a nut. And I tend to have it more with seedlings than I do with seed, but that's why I was so surprised to see this on a seed derived planting planted in the spring. We planted, it was sleeting, it was absolutely miserable planting this site. But yeah, they were up probably, I don't know, a foot, 12 inches pushed out of the ground.
I believe it. I believe it. Yeah, we've had it trouble before too, but I thought maybe we fixed it with the spring planting, but apparently not. So it's probably right.
I think it's a function of how much, and maybe Laurel can correct me, but I think it's a function of clay content and how much is still in there, but
Yes.
I'm not positive. All right, well, I don't know if there are any other, that is the end of our formal presentation. Laurel, thank you. Jenise, thank you. Jim Walliser, I think he's already gone away, and so has Jim Finley and Kim, but I really appreciate them all showing up and sharing a nice little tribute for Jim Walliser and his work. Mary, do you have any final words for the chapter? As I think this is your last meeting as president of the chapter. Thank you for all you've done these past couple of years.
Well, Sarah, again, thank you for running the meeting on Zoom. And I want to thank everyone who came. And I especially want to thank our speakers. It was absolutely fascinating. And it's something that I personally knew next to nothing about. And when it comes to growing chestnuts. And thank you very, very much for taking time out of your Saturdays to speak with us.
All right, thanks everybody. This is recording. I'll put that together and post it. You guys will all get an announcement when it's done. And Laurel, Jenise, I'll certainly be in touch. And thank you guys. Have a great rest of your weekend.
Thank you so much.
All right, bye everybody.
Bye-bye.